I'm Dr. Binu. The second module in the second unit is sensors and actuators. Sensors are nothing but sensors and actuators are the functional basic functional elements in the IoT system. The differences between the transducers, sensors and actuators are defined by means of different parameters. The first parameter is definition. The transducers convert energy from one form to another. The sensors are converting various forms of energy to electrical signals. At the same time, the actuators converts electrical signals into various forms of energy, typically mechanical energy. It can be used in various domains. Transducer can be used to represent a sensor as well as an actuator. But in the case of sensor, it is an input of a transducer. Actuators are output transducer. The function of the transducer is it can work as a sensor or an actuator but not simultaneously. Sensors are used for quantifying environmental stimuli into signals. Actuators are used for converting signals into proportional mechanical or electrical outputs. Examples of transducers are any sensor or actuator can be act as a transducer. Some of the examples of sensors are humidity sensors, temperature sensors, anemometer, manometers, accelerometers, gas sensors, etc. Examples of actuators are motors, force heads, pumps, etc. Sensors can measure or quantify or respond to ambient changes in the environment or which is connected to the deployment. It generates responses to external stimuli or physical phenomena through input. It is intensive to any other property besides what it is designed to detect. It does not influence the measured property. What is meant by sensor node? It is a combination of a sensor or sensors, a process unit, a radio unit, and a power unit. The various nodes are capable of sensing the environment. They are said to measure and communicate the information to other sensor nodes or remote servers. The basic functional blocks of a typical sensor node which is available in IoT is various sensors. The sensed data, the data may be a light, temperature, force, position, speed, pressure or chemical, can be sensed by different varieties of sensors. The collected information by the sensor is in the analog form which will be converted to the digital by means of ADC, analog to digital converter. The digital data is given to the processor for processing as well as control operations. Then after conversion, the data is given to for storage purpose or the various, in order to transfer the data, different communication modules, that Wi-Fi, Bluetooth, Zigbee, LoRa, RFID, Z-Wave or GSM modules are used. Some of the examples of sensors are described in this diagram. Camera sensor, color sensor, compass and barometer, current sensor, digital temperature and humidity sensor, flame sensor, gas sensor, infrared sensor, rainfall sensor as well as ultrasonic distance measurement sensor. We will see the sensors in a smartphone. The smartphone consists of various sensors like proximity sensor, magnetometer, accelerometer, humidity sensor, moisture sensor, microphone, fingerprint sensor, thermometer, touch screen, light screen, pedometer, global positioning system, etc. The various sensing types are divided into 4 categories based on the nature of the environment being sensed and the physical sensors being used to do. The first one is scalar sensing, the second one is multimedia sensing, third hybrid sensing, and virtual sensing. The sensors can be categorized based on how they produce, whether they produce energy output or for their, in order to produce the output, whether they require any external power supply or not. In this category, it is divided into active as well as passive. In order to produce the output, if they require external power supply, means that are called as active, whether they simply receive energy, they require no external power supply, means that are called as passive. Another category is invasive or non-invasive. The sensor is a part of the environment which is measuring, means it is called as invasive. It is external to it, means it is non-invasive. Another category is contact or no contact. In this category, whether they require physical contact with what they are measuring, means contact. If they are not having any physical contact, means no contact. Absolute or relative, based on whether they measure on absolute scale or fixed or variable reference, means that are called as relative. Other categorizations are position type, occupancy and motion, velocity and acceleration, force, pressure, flow, acoustic, humidity, light, radiant, temperature, chemical, biosensors. Next we will see actuators. Actuators are a machine or systems component that can affect the movement or control the set mechanism of the system. Control system affect changes to the environment or property they are controlling through actuators. Examples are motor. The differences between sensors and actuators are: in the real world, the physical environment, the various parameters are sensed by the sensor, which is given to the digital representation is given to the processor. Actuators are based on the control, the reaction is given as a useful work. Classification of actuators. Actuators are divided into 7 classes: hydraulic, pneumatic, electrical, thermal or magnetic, mechanical, soft memory polymers, shape memory polymers. Examples of mechanical actuators are lever, screw jack, hand crank. Electrical actuators are thyristors, bipolar transistor, diode. Electromechanical actuators are AC motor, DC motor, stepper motor. Electromagnetic actuators are electromagnet, linear solenoid. Hydraulic and pneumatic actuators are hydraulic cylinder, pneumatic cylinder, piston, pressure control valves, motors. Smart material actuators are shape memory alloy, simply it is called as SMA, ion exchange fluid, magnetoresistive material, bimetallic stripe, piezoelectric BIMOF. Micro and nano actuators, examples are electrostatic motor, microvalve, comb drive. Hydraulic actuators works on the principle of compression and decompression of fluids. Pneumatic actuators works on the principle of compression and decompression of gases. Electric actuators are used to power an electric actuator by generating mechanical torque. Thermal or magnetic actuators have very high power density, compact, lightweight and economical. These actuators do not require electricity for actuation. Mechanical actuators, in this the rotary motion of the actuator is converted into linear motion to execute some movement. The next subdivision is smart objects. Smart objects are quite simply the building blocks of IoT. If a sensor is a standalone device that simply measures the humidity of the soil, it is interesting and useful, but it's not revolutionary. If the same sensor is connected as a part of an intelligent network that is able to coordinate intelligently with the actuators to trigger irrigation system as needed based on those sensor readings, we have something far more useful. The various trends in smart objects are size is decreasing, power consumption is decreasing, processing power is increasing, communication capabilities are improving, communication is being increasingly standardized. Some of the limitations of smart objects in wireless networks are limited processing power, limited memory, lossy communication, limited transmission speeds, and limited power.